All right, in our last video on solving in our last video on rational functions, before we start actually graphing, we're going to be looking at solving rational equations. Now, again, rational equations are equations that have not factors, fractions in them where the denominator is a variable. And so what we're going to be looking to do is a process called clearing the fraction. We want to essentially get rid of the fraction to make the problems a little bit easier to work with. Now, in order to do that, we're going to need to find out what the least common denominator is, and then we'll multiply through by that denominator. So as an example, our first one here, we're going to have 2/5 plus 1 over x equals 3/4. So we've got three fractions. We've got the 2/5, the 1 over x, and the 3/4. What we're looking to do between those three fractions is to figure out what the least common denominator is. So I'm going to spell that out here. The LCD equals, and so if we look at our number parts of the denominators, we have a 4 and a 5, and I think I can turn those relatively easily into a 20. And then we also have that variables part of our denominator, so it'd be 20x. So the process of clearing the fraction says we're going to take our LCD, our denominator, and we're going to multiply through by that. So take 20x times that. Now, we're not going to multiply the denominator. We're really just multiplying the numerator by that, because 20x really is 20x over 1. So take each fraction. 2/5 times 20x gives me 40x over 5. And we'll reduce that in just a minute. Plus 20x over x equals 60x over 4. We're going to reduce each of those. 40x divided by 5 is really 8x. 20x divided by x is really 20. And 60x divided by 4 is 15x. And so then we're looking to solve that for x. So now this is really just an algebra 1 equation. We can take away 8x from both sides. And we're going to have 20 equals 7x. So x would equal 20 over 7. But what we want to be careful of is when we get an answer when dealing with rational equations, we have to make sure that that number actually works. So what we're trying to do is double check and make sure that that's not one of our excluded values. So I'm going to list out my excluded values here. And that's anywhere the denominator can equal 0. So the first one, I got a 5. 5 can never equal 0. I effectively ignore that. X can equal 0 when x is 0. So can't equal 0. And then 4 can never equal 0, so don't worry about that as an excluded value. So our only excluded value was 0, and we got something different from that, so there is our answer. And don't freak out if you get correct. That will happen periodically. In our next one, number 2, we have 3 minus 6x over x plus 1 equals 6 over x plus 1. So again, our LCD is the first thing we're looking for. Before I do that, though, I'm going to turn that 3 into 3 over 1 so I can clearly see that that's a fraction. And so my LCD would be 1 times x plus 1 would be my least common denominator. And while I'm at it, let's do the excluded value. So because that denominator is x plus 1, my excluded value would be that x cannot equal negative 1. So once I get my answer, I'm going to double check that it doesn't equal negative 1. So now that I have my LCD, I'm going to multiply through by that. So take x plus 1 times each of those pieces there. So I've got 3 times x plus 1 over 1 minus 6x times x plus 1 over x plus 1 equals 6 times x plus 1 over x plus 1. So to cancel out, the x plus 1's here and here. And now my equation is really this. So 3 times x plus 1 is 3x 3 minus the 6x that's there, and that has to equal 6. So I'm looking to solve to bring the x's together. 3 and negative 6 is negative 3x. Take away 3 from both sides. Negative 3x equals 3. And divide by negative 3, x ends up giving us negative 1. Uh-oh, that's our excluded value. So what that tells me then is there's actually no solution because our only possible solution was the one that was an excluded value. That's very big concern for us. All right, let's do another one. Number 3, we're going to have 9x minus 6 over 5x minus 3 plus 7x minus 3 over 10x minus 6, and that equals 1. So on first glance, it looks like those denominators are completely different. However, it may be in our best interest to look to factor a GCF out. So I could actually take a 2 out of the 10x minus 6, giving me 5x minus 3. Look at that. That's the denominator that we want to be looking for. So our LCD is going to be 2 times 5x minus 3. And so our excluded value would essentially just be this part here. I don't worry about that 2 because 2 cannot equal 0. This would be 5x minus 3 equals 0. And so let me put it on the side here. When I solve that for x, I get 3 over 5. So that's my excluded value. If I get that as an answer, not a problem. Okay, so now that we know our LCD and our excluded values and what to be on the lookout for, I'm going to take each fraction and multiply it by 2 times 5x minus 3. Again, I'm not really going to do a whole lot of multiplication right now because I know some things are going to cancel. And that's really what I want. Oop. And I have to actually multiply. There we go. Kind of skipping a step here. My apologies. And so that denominator is 2 times 5x minus 3. And that equals 2 times 5x minus 3 all over 1. So now we pull out our canceling pen. 5x minus 3 cancels in that fraction. In this fraction, we have the 2 and the 5x minus 3 cancel, and then nothing on the other side. So I'm going to take 2 times 9x minus 6, which is 18x minus 12. And the second fraction just becomes 7x minus 3. And my third piece would be 2 times 5x minus 3, so 10x minus 6. Combine like terms, we've got 18 and 7. That's 25x. Negative 12 and negative 3 is negative 15. And we can solve. So bring 10x over gives me 15x. Bring the 15 over, that gives me 9. And x equals 9 over 15, which, oh man, it happened again. So we take the 3 out of each of those, and I'm going to get 3/5, which we know can't work. So we have no solution once again. Now, this doesn't happen very often. It just happened on 2 of the 3 examples we've looked at so far. All right, we're going to set up the next one. I don't think we're going to finish the whole thing because, we're running short on time. I don't, have a 20-minute video. So the next one, we got x over x plus 2 plus x over x plus 1 equals 3x plus 2 over x squared plus 3x plus 2. So, yeah, it looks like all the denominators are completely different. But again, let's be smart and actually factor that one, x plus 2 and x plus 1. So this is going to make it a little bit easier for us to solve, because at this point you might see that our LCD is just each of those factors, x plus 2 and x plus 1. In our excluded values, this factor right here, x plus 2, when we set that equal to 0 and solve, x can't equal negative 2. And when we do the same thing with the second one, x can't equal negative 1. So those are the values that we cannot use. Our next step, take our LCD and multiply through. All right, here's the mess. X times x plus 2 times x plus 1 over x plus 2 plus x times x plus 2, x plus 1 over x plus 1 equals x times, oh no, sorry, got a little ahead of myself there. Oh boy. Actually, 3x plus 2 times x plus 2 times x plus 1 all over x plus 2 times x plus 1. So let's cancel some things out. Those x plus 2's are gone. The x plus 1's cancel here. And then all this stuff here is going to cancel. So what I've got is x times x plus 1, that's x squared plus x times x plus 2 is x squared plus 2x. That equals 3x plus 2. Now at that point, I'd be looking to bring everything over to the other side and trying to solve it. So I'm going to have 2x squared plus 3x equals 3x plus 2. So at this point, I can actually eliminate the x's. And I have an equation here that looks like 2x squared equals 2. So if I solve it by reversing, probably the easiest way in this case, that'll give me x squared equals 1. So my solutions then, once I take the plus or minus square root, it is a plus or minus 1. In other words, x equals 1 and x equals negative 1. But looking back at our excluded values, negative 1 we were told does not work. So we have one workable solution. So solving rational equations, the beginnings of it are very much like adding and subtracting rational expressions, in that we want to find a least common denominator. But instead of changing each denominator to that, we're going to multiply through by the denominator to completely get rid of it. What's left is generally linear, but sometimes we're going to have some quadratic equations, but much simpler than what we originally started with. We're trying to solve this equation down here at the bottom as opposed to what we originally started with.